We're doing like a quizzes for a review. We're going to do that in class tomorrow. So it'll be reviewing like classifying, standard form, adding, subtracting, multiplying, and now today we're going to bring in dividing. So again, make sure you have turned in that paper. For my people who just walked in, the paper we were working on yesterday, make sure it is turned into the tray. All right, today we are going to divide. Okay, we're going to divide with coefficients. We're going to divide with variables and exponents. Not brand new stuff. We are just doing polynomials. So we're used to just dividing like one piece with another one piece. Now we have 2 terms or 3 terms or 4 terms being divided by a monomial. What is monomial? Monomial. Just one. So we're only going to divide by just one term today. Okay, but the top, it might be 1, 2, 3, 4 or more. Okay. Let's remember our quotient rules. When it comes to our exponents, if we're dividing like bases, what do I get to do with my exponents? Yeah, we get to subtract them. And we always do top minus bottom or bottom minus top. Always top minus the bottom. Good. So if we get a negative number, that might happen. What do we do if we get a negative exponent? We need to put it into a fraction. We need to drop it down to the denominator. Right? I'm going to work through the odds. Okay? And then you'll be responsible for the evens tonight for homework. Okay? So I'm working through the odds. You're going to be responsible for the evens. So let's start off with 36x to the 5th over 4x cubed. So we are going, I like to split them up into like terms. I have my coefficients, 36 over 4, and I have my variables, x to the 5th over x cubed. Does 36 over 4 simplify? Just 9, right? That's nice. So that's just 9. How about x to the 5th over x to the 3rd? Yeah, if we subtract them, we get x to the power of 2. So my 2 pieces, 9x squared, that is our simplified answer. Like that. Do you remember something called domain restrictions? Remember those words? It's not asking about it, but if I asked, does this have a domain restriction? You would tell me yes, because we have a variable in the denominator, right? What is that variable never allowed to equal? 0. Okay. So if I said, what's your domain restrictions? Your domain restriction would be that x cannot equal 0. Again, it's not part of the directions, but I just want to remind you, we did talk about it in the past. So I'm just bringing it back up. Okay. Because that would make our fraction undefined, right? We can't divide by 0. All right, let's go over to number 3. A little bit more happening here, right? But we can still split them up, okay? I'm going to split them up with 20 over 24. I'm going to split it up. We're going to do all the colors. A2 over A3. I'm going to split up, what is that? B4 over B4. And then there we go. C6 over C3. If you need to split them up, split them up. Okay? If you have different colored pens, you can do what I'm doing. Okay? Now let's simplify piece by piece. So let's do our coefficients first. 20 over 24. So it can't simplify into an integer, but it can simplify, into just a simpler fraction. They can both be divisible by 4 to give us 5 over 6. Excuse me. All right. A2 over A3 simplifies to what? Right. It's a to the negative 1 power, which means a to the power of 1 is going to drop down to the denominator. I'm going to do it above it to show. There we go. All right, B4 over B4. Okay, so it's b to the power of 0, which equals 1. They cancel out. This is equal to the number 1. Do I have to put times 1 in my equation? No, I'm not going to. All right, C6 over C3. When you subtract them, you get C3. So is it going to be with my 5 or with my 6 in my answer? Up top with my 5. So we have 5C3 over 6A. So you don't have to put the exponent of 1 if you don't want to. These are the same thing. How are we feeling about this? Okay-ish, that's fine. We can be I've only done 2 problems. It's okay. Okay, so what we just did is stuff we have done in the past with a monomial over a monomial. Number 5, now I have a binomial over a monomial, right? I have 2 different pieces. I can only divide by 8 if everything up top can also be divided by 8. So what we can do is we can set them apart into 2 separate fractions. Okay, so we can have 40x squared over 8, and we have negative 8x over 8. It is divisible by 8, yep. So what is 40 over 8? 5. And the x squared just stays, right? Okay, so that first piece becomes 5x squared. All right, how about negative 8x over 8? Negative 1x. There we go. So since 8 was a constant, you were able to simplify that to the coefficients up top. They were all divided by 8. That gave me 5, negative 1, and that was the 1. Is essentially what we did. So since they were evenly divisible by 8, there is no more denominator. All right, 7 is different. Look at my denominator. It's not just a number this time, right? It's a coefficient and it's a variable. So they both have to be able to be divided out of each piece or simplified out of each piece for us to be able to break it apart. Okay, so let's do 12x3 over 3x2. Let's just do that one piece first. 12 over 3, does that simplify? To what? To 4, okay? x3 over x2, does that simplify? To what? What is 3 minus 2? That's just 1, right? So this becomes 4x. Just that piece does. Okay. So that is part of my answer. My other part's going to come from 15x over 3x squared. Does 15 over 3 simplify? That's 5. How about x over x squared? Well, it does. It's going to be x to the power of negative 1. So this is going to be 5 over x. So when we put these two answers together, we're going to have 4x and 5 in my numerator, which is what? Hold on. 4x times 5 is in my numerator. Oh, I lied. That's definitely a plus. What am I doing? What am I doing, guys? We have 4x. There we go. There's a plus right there. Plus 5 over what? Y'all, I am messing this up. Okay. Regroup. Go back. I got this. We have 4x plus 5 over x. I was making that way too hard. I didn't need to make it that hard. I don't know what I was doing. So because of this plus sign, we add our two pieces together. Number 9, what do I have in the numerator of this fraction? Well, there's a minus happening now. There's a plus. What if I asked you to classify that polynomial? What would you classify it as? That's half of the answer. Trinomial. What's the other half of the answer? What's that? What's that degree? The degree is 3. This is a cubic trinomial being divided by What's that denominator? Classify that. A what monomial? What's the degree of the bottom? A 1. So what's the degree of 1? Linear monomial. There we go. What's today? Wednesday? Throwback Wednesday. I know it feels like I don't even know what it feels like a Monday. Okay. So we have 3 pieces that we are going to divide by 3c, all right? If you want to break them up individually, you can. What is 18 divided by 3? 6. What is C3 over C? There's a little one right here. C2, right? So that first piece breaks down to be 6C2, right? Do we need to see it? 18C3 over 3C1. 18 over 3 gave me the 6. C3 over C1 gave me C2. All right, now the middle. We have negative 21C squared over 3C1. So negative 21 over 3. Negative 7. C2 over C1. C1. Good. All right, and then my last little piece. We have 3C over 3C. What is 3 divided by 3? What is C divided by C? 1. So what's going to go on the end? Just a 1. The whole thing turns into a 1, a positive 1. And this is our answer. Okay. We are dividing out a common factor with all these polynomials. Specifically, we're factoring out the greatest common factor of each one. When we go into factoring polynomials later, we'll always look for if they have a GCF, which is what we're doing today. Can I divide everything by the same greatest common factor? It'll simplify it and help our factoring become easier. Okay, let's try 11. Oh no, we have 2 variables. Is that going to change anything I'm doing? No. Keep your coefficients together, keep your A's together, and keep your B's together. Okay, don't change what you're doing. So my first group, we're going to do 6A squared B over negative 2AB. Okay, so 6 over negative 2 turns into negative 3. Good. A2 over A.
It should be
A1. Good. And B over B. And careful, it's not 0, right? What does it turn into? It turns into a 1. Okay, anything divided by itself turns into the number 1. So we don't say times 1. All right, so far we have negative 3A. All right, the next part of my answer, we're going to now do negative, keep that negative with it, negative 12AB squared over negative 2AB. All right, what is negative 12 over negative 2? Good, it's a positive 6. A over A? Just 1. A over A cancels. It becomes A to the power of 0. Do we understand what's happening? We have A1 over A1. I can subtract those, so it becomes A to the power of 0, which equals just the number 1. That's what's happening. So to say something cancels out, we're saying it equals the number 1. Now B2 over B, B1, good. So we have negative 3A plus 6B. Is that in standard form? Yes. How do you know? The A comes before the B. It's in alphabetical order. Good. Beautiful. 1, 2, 3, 4, 5. Okay. It's becoming more fun, right? More fun. All right. Here we go. 14 divided by negative 7. Negative 2. A6 over A4. I'm sorry, X6 over X4. Thank you. X to the power of 2. And Y3 over Y. Is it going to be negative or positive?
No, it's going to be positive.
This one stays positive. So 3, remember there's a 1 down here. 3 minus 1, it stays a positive 2. So no fractions. Not yet. We'll see what happens. All right, my other side. Okay. So negative 49 over negative 7 is positive 7. How about x5 over x4? X to the positive 1. Good. And then how about y9 over y1? Y8. Did I have to drop anything down? So is this my answer? Is it in standard form? Yes. Because even though y has the highest degree, what trumps that? That x comes first in the alphabet. So x squared needs to come first, then x1. There we go. Feeling good? Are we feeling better? I'll do that. I'll ask that question. Better. Okay. Here we go. 15. ABC. Yep. Easy as. There you go. All right. 20 divided by 5. That is 4. A6. Keep going. Ooh. Uh-huh. Nice. And I don't have to put c to the power 1, right? But I could if I really wanted to. But I don't have to. All right. Good. That was easy. Are we all good with that? We know how they all just drop down 1 degree? Because each of these have a degree of 1.
And the second part is negative 1.
Yeah. The next part, negative 5 over 5. Negative 1. And look at that. A cancels, B cancels, C cancels. So that's our final answer. Negative 5 over 5 gives me negative 1. And then technically we're saying times 1 times 1 times 1, right? A over A is 1. B over B is 1. C over C is 1. So that whole thing just simplifies. Oh, not negative 5. What am I doing? To negative 1. You think you're ready to try one yet? I think you should try number 17. Yes, you try number 17. You can do it. All right, check your answer with mine. You should get 4c squared d plus 6c squared.
I just had to be
What did I do? What did I do? Oh, I did mess up. I did it on purpose.
Okay.
12 divided by 3 is 4. C5 over C2 is C3. D4 over D3 is D. On my other side, 18 over 3 is 6, positive 6, so plus 6. C4 over C2 is C2. D3 over D3 is nothing, right? Remember? D3 over D3 is D to the power of 0, which is just 1. So I'm not going to put times 1 right there. That doesn't make sense. So those cancel out. These pieces cancel out. Just on that side, though. Is it in standard form? Yes, we're in alphabetical order. So C's come first, highest degree to lowest degree, and we're good to go. All right. Here we go, 19. We have a fifth degree trinomial divided by a quartic monomial. Yeah, okay. We are going to divide out the greatest common factor of 5x to the fourth from each piece of that trinomial. So if I do 15, we'll do this piece first. 15 divided by 5. 3. X to the fifth over x to the fourth. X to the power of 1 or just x, however you want to write it. Okay, now let's do this middle piece. Oh, I changed the color. We're going to get to it. What is negative 25 divided by 5? Negative 5. What is x3 over x4? Negative 1. I'm going to move stuff later. And now this last piece. 5 divided by 5. It's a positive 1. x2 over x4. Negative 2. So my suggestion would be to do each piece first and then move stuff around. Okay? Which pieces are going to get moved to a denominator? So it's 5x1, right, plus x squared. Those get moved to the denominator because both of those terms had a negative exponent. So the entire term gets brought down. Hold on. See, y'all make me second guess myself. Hold on. Let's double check. Yep, okay. Just kidding. The 5 doesn't have a negative exponent, does it? Just the x does. Nope. Because there wasn't parentheses. See, I'm glad this happened. There wasn't parentheses, right? The only piece that has the negative exponent in the first piece is just the x. The only piece that has a negative exponent on the second piece is just going to be x squared. So this is going to be equal to, we have 3x minus 5 over x, and then plus 1 over, it got erased.
Yeah, that's what I got. 3x minus 5 plus 1 over x to the power 2.
Yes, that is the final answer. Do we need to do it again? Are you sure? Okay. So 3x stays 3x. There was nothing negative going on. 5x to the negative 1, x to the negative 1 needs to get dropped underneath the 5. So that middle term needs to be negative 5 over x. And then 1x to the negative 2, that last term, x had a negative exponent, so x squared needs to drop underneath the 1. What's your question, Abraham? Because my first term doesn't have anything negative. They are 3 individual pieces. When we break it up, it is 15x to the fifth divided by 5x to the fourth by itself. And then next to that, we have minus 25x cubed over 5x to the fourth. So they're each being divided separately by the same denominator. Then we have 5x squared over 5x to the fourth. Like that. So they're 3 individual pieces. So my purple turned into just 3x. That red piece in the middle, 5 stays on top, but we got x to the negative 1 power, so x went under the 5. Does that help? 5 over 5 is 1. x2 over x4 is an x to the negative 2, so that green x squared had to go under that last piece. We good? That was a good one. Can we still do it together? Yes, we can still do it together. Yep, last one with me. And then you should have about 15-ish minutes to work on the rest. All right, so we have a trinomial over a monomial. Trinomial means we have 3 separate terms being divided by the same common factor. So treat it as 3 separate pieces. My first piece is 30C5D9 over 3C2D2.
So 30 and 3
is 10.
It should be C3. And D, it'll be D7.
7. Good. I didn't get any negative exponents, correct? So that piece, there's no fraction. They all stay together. All right, my middle piece. This color. So we have negative 12C4D8 divided by the same common factor of 3C squared D squared. So negative 12 over positive 3. Negative 4.
It should be C2.
Mm-hmm.
It'll be D6.
D6. Nothing was negative, so I didn't have to drop anything down. It's something. Let's see. We have positive 3C3D7 over 3C2D2. So 3 over 3 is 1. Yep. C1 or just C, whichever way you want to write it. D5. Did we have any negative exponents? No. So 21, I think, was actually maybe a little bit easier than 19. Nothing had to drop. Didn't get any negative exponents. Before I boxed it, I should have checked for standard form. Was it in standard form? Yeah. Even though D has the power of 7, 6, and 5, what trumps that?
C.
The C coming before D in the alphabet. So C has to go first. What's that? There is no 22.
Can you do 20 as well?
Oh, 20 as well? No, that's yours. You do it. You are doing evens. I believe in you. All right. So for the rest of the class, you're going to work on your evens. If you get it done, I will stamp it and check you off. If you don't get done, you're going to have to show it to me tomorrow.